Welcome, everyone. Thank you. We've all seen the power of microservices. They allow us all to build scalable, resilient applications. But what comes next? Today, we're exploring a new paradigm, agentic AI. We'll make the case that intelligent, autonomous agents represent an evolution. Microservices 2.0, if you will. We'll go from theory to hands-on demo, showing you how to build these systems using Google's Agent Development Kit, the Agent-to-Agent protocol, and Anthropic's Model Context Protocol. My name is Edward Villalba. About 16 years working in cloud services with a collective 25 years in the IT industry. I've done everything from Fortune 100, Forward 100 to US government agencies, co-authored Kubernetes best practices from O'Reilly Press, and live here in Austin, Texas with my wife, my child, and my two dogs, Bear and Atreyu. If you don't see me online or working on Agentic or AI on GKE, I'm also a private pilot enjoying the beautiful clear skies of Central Texas. My LinkedIn is here. I am a senior outbound product manager for artificial intelligence on GKE. So I focus on containerized orchestration on our Google Kubernetes engine. And you'll see today as I talk about this on why this microservices and GKE is a perfect fit. So agentic AI, let's talk about that, right? We've all leveraged microservices to build scalable, resilient applications. They've been foundational. But as systems grow in complexity and user expectations demand more dynamic, intelligent interactions, we face a new frontier. Today, we're making the case for agentic AI, intelligent, autonomous agents, as the natural evolution. Like I said, microservices 2.0. We'll show you how you can build these sophisticated tools using a suite of software tools or frameworks. Two that were contributed by Google to open source. One is the Agent Development Toolkit, and the other one is our Agent-to-Agent Communication Protocol. And finally, Anthropic's Model Context Protocol. Now, often the A2A and MCP are seen as potentially opposite, but in reality, they are very collaborative in nature. And as you'll see when I go through the demo, that we actually use them together. And they serve two different kind of purposes. And I'll kind of go through that process as we go through it. So if we think about existing microservices and our traditional microservices architecture, things like API gateways and services, and then we compare them to like future agentic architectures, where we look at orchestrator agent and specialized agents, we can begin seeing that at first, microservices, while very powerful, often become reactive. They respond to direct API calls with predefined logic and steps. The challenge today is building systems that can handle ambiguity, plan multi-step tasks, and adapt to new information or user input, tasks that require reasoning, not just execution. So how do we get specialized systems to collaborate intelligently? This requires new standards for communication and a new way to build the services themselves. This is where agents come in. So as I mentioned, we have three core tools. If we think of ADK, the Agent Development Toolkit, this is basically the framework for building our agents, for creating paradigms that are very similar to microservice patterns, but building them with agents in mind, orchestrating the work of all of these agents together, but also providing a communication protocol to allow for security, to allow sharing of services and understanding and service discovery as well. Now, if we take also MCP, or the Model Context Protocol, this is a standard put forth by Anthropic into the open source for how agents use external tools. So an example would be using existing APIs or leveraging existing microservices that you've exposed their APIs already and be able to call those APIs and do other actions on behalf of the user by the LLM, and allow the large language model or the generative AI model to determine which tools to use and based on the natural language request or the processing. And then finally, the A2A. This is how other agents talk to each other, regardless of the framework that they've been built on. So you can have one agent that was built with LangGraph, another one built on Crew AI, another one built with no framework. You decide all the different agents, how they're built, potentially even third-party agents, and then be able to allow them to communicate and also discover each other and understand what tools or what offerings each of these agents allow. So the orchestrator or the main agent that will orchestrate all the work can understand what to call, when to call it, and how to call that agent, and how to respond, how to get the response back. Now, we're going to go through a quick code review, for lack of a better term, but I wanted to kind of give you a big picture of what our demo setup would be. This is a very kind of trivial example, but I think it serves the purpose as I go through it. The first is just a high-level architecture. We're going to have a host agent. Consider it like a router. And we're going to basically do this through a multi-agent Airbnb plan. So the central host acts as an intelligent router. It makes a user request in natural language, like find me an Airbnb in Austin and tell me the weather. And then the host agent's job is to decide which specialized worker agent should handle the request. And then based on the agent's discovery and finding out what their capabilities are through the agent card, the Airbnb agent is used for finding property listings, and the weather agent is used for getting forecasts. All the communication between the host and the workers happens via an agent-to-agent like protocol based on RPC. The weather agent gets its real-time data by communicating with an MCP server that wraps a weather API, and the Airbnb agent built in LandGraph also uses a wrapper for an API to talk to Airbnb. And now all of these agents were built using Google's ADK. So let's go a little bit deeper and let's look at the application itself. We're going to kind of go compare. So first, I'm just going to give you a high level, and then we're going to go right into the code. So if you think about like the weather agent as an example, it gets its real-time data from an external API using MCP. So think of MCP as that capability to talk to or call out to tools outside of the application itself. It could be an external API through a web agent. It could be a tool built into the service itself or into the server that's running the agent. But regardless, its ability for the LLM to be able to call tools in a unified manner. And I think Anthropic loved using this, like the USB-C of agent calls and LLMs. So it's being able to call any of these tools, regardless of where they are, in one unified way. So let's kind of look at the code real quickly. So we'll come over here to our code index. And up here, I basically have my weather code set up. And this is just the main here. But what you'll see, what I wanted to call out is the agent skill, and more importantly, when I'm constructing the agent card. And this is information that I want to be available to the orchestrator or the host agent, so that when it calls and says, hey, what agents do I have available? It's able to understand what it does and its context for the LLM as it begins to decide what it's going to do or what tools we'll use based on my natural prompt. So if I look at the MCP code, this MCP code is actually what calls out to the weather service and actually does through geolocation, gets the city state, and then will then identify the forecast by city, state, and so on and so forth. So here's the meat of the code that actually calls the forecast API, and it describes the tools and the parameters, and it serves as an adapter that handles the actual call to the underlying API. Now, if we look at the agent code here, this is where the ADK agent itself sits. It's an LLM agent. It uses some what I call a function tool that acts as an MCP client calling our MCP server. So it actually understands the tool set and says, hey, I need to call this weather mcp.py file. The agent doesn't need to know about the weather API specific details, so it's a level of abstraction. It just knows that it has a get weather tool available through the MCP. And this is that power of standardization. Now, if we go to the next level of depth, okay? Sorry, let's go here. Now, how do I route all of this stuff? My host agent, which is basically an A2A client, will be calling in based on, and I have a UI we'll show you in a minute, but it basically has a routing agent and a remote agent connection. The routing agent basically is a clever use of an ADK LLM agent. Its only job is to perform classification. It says, based on the user's query, should I go to an Airbnb agent or should I go to the weather agent? The LLM's response will be the name of the agent to call. So it says, hey, based on what I'm seeing in my natural text, which agent should I call? And then for the remote agent connection, once that router decides who to talk to, the remote agent connection then handles the how. It acts as our A to A client making a standard HTTP request to the chosen worker's endpoint. This is our agent to agent communication layer. And again, if you look at my code here, let's go back to our code. If I go and expand our Airbnb code, you'll notice that our Airbnb code, if I look at the actual agent itself, this is a land graph agent. So I built it through, let's go to agent here, PY. So this is a LangChain land graph agent. So regardless if it's a land graph agent, crew AI, it doesn't matter what format. As long as I've worked together with A2A and added the A2A protocol to it, I'm able to now use this agent and allow it to talk to our other agents within the overall service. Again, very similar to how our microservices were put together, right? So when I look at this agent code base for the Airbnb, not only do I have, again, just to make the basic agent and how do I call the agent, and this is the external call to Airbnb, but it actually shows the list of tools available to it. And then from our main, we're then able to call it. And also, as I showed you earlier, to be able to see the agent card for this specific agent. So now, not only what is it, but what does it do and what does it offer me and what kind of input and output is expected by this agent, okay? So let's go back here. Now that we understand it, let's look at the whole demo end to end, right? So I already have the services running. So I have the weather agent set up as a different service that's running on its own port. I have the Airbnb agent set up running, it's on its own port. And then I have the host agent also set up and it's running a Gradio UI. Now, this is important. Why did I create them as separate services? Again, if your premise correct is here that this is the new microservices 2.0, we should be able to containerize each of these applications separately, allow them to talk over a network connection, and therefore be able to host them in container orchestration runtimes very easily, and allow that communication pattern, JSON RPC, and regular web calls to talk to each other. And we're going to dig into that a little bit later when I talk about how this would potentially look on something like GKE as an example. But let's kind of run through and look at the terminal again, and let's see what we're running here. So my host agent is basically, as I mentioned before, it is running a Gradio. And one of the things that I notice here is you'll see that I have my remote agent connection and my routing agent. So those are the two kind of services that are, hey, which agent should I call based upon the context of the session? And then once the router makes an intelligent decision, the connection agent then does the call to the proper A2A client. And then in main, I'm just basically pulling up the UI and making it available. And one of the things I want to do is make sure I get the agent cards. So just to show you, here I have my Airbnb client running. It is running on 0002, 10.002, and you can see I'm getting some requests from there. My weather API is also running. And again, it's also running on another port, 10.0.0.1. And finally, my host UI. Now, the host UI, you'll notice when I call it up and when I bring it up, it immediately begins to interrogate and it gets the agent cards and it comes back with what agents are available and what are their capabilities. So in this example, this is my weather agent. It says name weather agent. The preferred transport is JSON RPC, and then what skills it has available and some examples of the skill and the actual ID and what port and URL it's on. Same thing with the Airbnb agent here. So again, what's the skill, what's available, and what port to talk on. So now they've discovered, so now we have service discovery. We found the agents that are available. The orchestrator, the host agent now knows how to route based on those things. And now I have a chatbot listening on port 8083 that'll allow me to then integrate with and talk to it. So what does that actually look like? Let's talk to our chat agent here. So we'll go ahead and ask it a question. What will the weather, let me spell it correctly, be like in, let's pick a nice little town that I want to go to. Let's go to Napa Valley, California. We'll just put CA. You should be able to find that out. This weekend, August 15th through 17th, 2025. All right. So at this point, the router is picking up that request. It then determines that it needs to call the weather API, and now it responds back with a JSON RPC that then I pull out that part that gives me my response. The weather in Napa Valley, August 15th through 17th, will be sunny with a high of 88 and a low of 58. That's beautiful. And a 0% chance of rain all 3 days. So this is great. The routing agent did its job, sent it to the weather agent, and it was able to get back the information and present it back in a perfect kind of chat interface for ease of use and ease of understanding. Now, again, if I go here and say, okay, go ahead and find me a room in Napa Valley for 2 adults this weekend, August 15th through the 17th. Yeah, 17th, 2025, near the let's just see what it comes back with. Let's just see if it prompts me for more detailed information. So I basically said, hey, I want to find a room in Napa Valley. And now it says, hey, to find the best room, you can provide a little bit of information. Again, this is that power of the LLM being able to interpret back the API calls to Airbnb and saying, I need more information to come back with a proper result. So now it's asking me, is there a specific town or area or a budget or a preference? And let's say I would prefer near Napa downtown. Okay, and now I should be able to get a response. And here it's again, the router identified that I should be talking to the Airbnb agent, finds it, does the call, had a narrowing or scoping down question, and then be able to send it out. Imagine trying to build all of that logic into just pure API calls with static conditional type eventing, things of that nature, be very complicated. In this case, I just have the LLM doing a lot of that logic and then coaching it through the prompting and through the agent tool on how to properly return back the information. So here I have 3 different options, and I can potentially go forward and ask it for more information about any one of those 3 options, but they all sound pretty cool. So what does this all mean, right? So again, I showed you what that agent looks like. But if you think about formalizing this analogy from microservices or traditional microservices 1.0 to agentic AI, microservices 2.0, we think about a service, right? What does the service become? The service becomes an agent. So we take those same services that we've always had and say, hey, how do we then identify these services that we have? It's no longer just defined in code, but they're intelligent oriented agents built with ADK. Okay, so we're going to go back to our code. So I'll kind of again inspect the code and then show you how that agent is built and then how we compare that to a service. So if we go back here, again, we're just going to pick the weather agent for now because it's relatively easy. And the code is here, but you'll see where when we build the weather agent, here we're defining the agent, and we're passing in a model. In this case, we're using Gemini 2.5 Flash, but I'm passing in this model through Light LM, and we're basically giving a description and some instructions, right? And these instruction set, again, is context. Context and prompting is key to how we drive the LLM and how we drive our tools to make sure they get back the responses in some type of predictable manner. And again, it can't be 100% predictable. That's the nature of generative AI. But in this case, we at least can get it down to a very specific way we want to have the information, how we want the LLM to find the information, and how we want the output sent back to us. So again, if you think of normal service creation, I'm defining this agent, but now I'm using kind of this agent code to say, hey, I want you to do this for me, and then this is how I want you to respond. Instead of building very static types and building dictionaries and identifying all of the things that you need to have, we're now leveraging this agent construct to be able to act as our service. Now, if we think about, again, the next layer of a microservice, how do we talk to individual microservices? We look at the API or REST gRPC as an example in the traditional method, but that evolves into more flexible, less rigid, task-oriented protocols like agent to agent. And this allows us to create orchestration agents and create workflows that have a little bit more kind of adaptability. And we're going to show you a couple of different paradigms in microservice patterns compared to agentic patterns in a minute. So again, if we go back to our code base just to kind of identify where the code is written, if we look at the API, the A2A component, that's here in our code when I talk about the weather agent. Now, when I look at the weather agent code base, let's go back here, it's a little bit extra. The code base itself, when we look at, let's go back, sorry, here, weather MCP, here is where I'm actually kind of identifying and building all of my major components, right? So here's all my tool, my forecast. So basically calling in all of the things that are available to the agent and being able to call those out and then identify what needs to happen and on what transport needs to happen. So this is a way how I define my code, and this is through our model context protocol, but I'm using my ADK to kind of build all of this up and then create this agent that then is able to call out, right? And if I look at my executor file, now this is where all of my logic exists. This is where I tell it based on my route, how I'm going to execute this agent, right? So this is actually where I'm initiating the weather executor class, which is a base from the base class agent executor. And it's able to then say, here's how I want you to process my request, get session ID. So I'm able to have history and be able to get all these things back, and then bring this back into the runner, or what we call the runner, to be able to get status back and be able to get those responses back. So this is the A2A component that kind of replaces my gRPC or my strict API calls from here. And this is how I build up that kind of execution workflow from here, okay? Now, let's go back to identifying, again, the components that make up the rest of the service. If we look at the next piece is where we have API integrations, where many times maybe you're calling out to third-party services or you're routing out to a third-party application. You then have to use some kind of bespoke integration services or integration work, rely on that code base from that third party. With MCP, this is that promise that it's kind of like that USB-C for LLMs and for agents. It allows me to plug in things like external APIs, things like maybe even database calls. All of these things can be kind of instrumented through the model context protocol, and then be able to then get the results back and abstract away the calls to those services and bring it back in a way that the LLM can then parse apart, and then in a response format that it's expecting, JSON RPC, and then be able to do or manipulate that context back once it gets it. And then finally, if we look at that routing agent, what is that acting like? It acts kind of like our API gateway, right? So if you think about how traditional web services, you're using some type of layer 7 or API gateway in front of your application, the routing agent is doing the same exact thing. But it's not just routing based on URL or a path. It's an intelligent agent that understands the intent of the user through natural language and routes the task dynamically to the agent that can best suit or solve that problem. And in some patterns, which we'll see in a minute, you can actually have multiple agents being called, and then the LLM or that central LLM be able to reason about the best way to answer the response based on multiple calls to multiple agents. So there's different patterns to show from that regard. So what do those patterns look like? So if we think about some of the different microservice patterns that have been in existence for quite some time now, and we map them to some of the more common agentic patterns. Let's look at exactly some of the, and then these are specific to ADK in some of them, but they are paradigms in other agentic orchestration tools as well. But if you look at like the coordinator dispatcher pattern, right? So versus our API gateway. So in our demo, the host agent acted as this coordinator dispatcher. And this is like an API gateway, but as I mentioned, instead of routing based on the path, it uses that LLM reasoning to route based on the intent, right? Very powerful pattern. And then if we look at like sequential pipeline pattern versus like a saga pattern in microservices, and you can have something like a sequential agent in ADK that executes sub-agents in a specific order and then passing state between them. And this is the equivalent of what we used to call the saga pattern in microservices, using for coordinated transactions across multiple services. So think of this as like using that for multi-step dependent workflows that need to pass information through to each other, and the state needs to be preserved as it goes across to all of these different agents. You also have parallel agent in the ADK. And this is very similar to a fork join, but we call it parallel fan out or gather pattern. And if you need to query multiple data sources at once, the parallel agent fans out requests to multiple sub-agents. And then this is a direct parallel to, like I said, that fork join, right? And parallel execution patterns seen in microservices. And it's great for reducing latency because you want to have multiple potentially small models that are servicing each different agent, and you want to be able to then, instead of synchronously, you want to be able to get the results back from each of those as quickly as possible in an async fashion, parallel, and then bring it all back for a reasoning agent to then summarize back the findings. And then if you think about the design-driven or domain-driven design, DDD, think of that as like hierarchical task decomposition in ADK. ADK allows you to build these hierarchy of agents, and a high-level agent can break down a problem and delegate to more specialized agents below it. And that's mirroring very similar to this domain-driven design, where you can kind of break down complex systems into smaller bounded contexts, as we called it in the microservices world. So again, a lot of parallels between the typical microservice patterns and this new agentic AI patterns that we see in tools like ADK and other orchestration tools for agents. Now, how does this relate to containers and so on and so forth, right? And why microservices? Microservices kind of brought the evolution through with containers, and then container orchestration engines with Kubernetes. Well, if you think about it, this agent-based architecture is perfectly suited for modern cloud-native deployments. Each agent, the host, the Airbnb worker, the weather worker, can be packaged as independent containers. They were all running on different network services. They're using network communication protocols like JSON RPC, HTTPS to talk to each other. And this makes the entire system ideal for running on a container orchestrator like Google Kubernetes Engine. GKE provides the scalability and resilience needed to run these agents as production-grade microservices. And you're not limited to proprietary models. So in this case, I was using Gemini, but you can host powerful open source LLMs like Gemma 3, Llama 4 on GKE. And with some of our newer capabilities, like our GKE Inference Quick Start and our GKE Inference Gateway, you're able to provide an optimized configuration for that open source model that you want to run based upon performance threshold or benchmarks that you're looking for, and then be able to easily deploy that into GKE on VLLM as your model server and host it on GPUs or TPU accelerators. And now you can have smaller, maybe fine-tuned models that you can then specify this agent uses this smaller fine-tuned model or this model, and another agent uses a different model, fine-tuned to the task it is responsible for. Where the larger, potentially the host agent UI or the planner UI, the orchestrator agent can then have a larger, much more robust reasoning type model associated with it. But again, all of this can be built now as separate microservices running in GKE, or any kind of container orchestrator. And then for even higher performance, when you're hosting on GKE with your model server, you can now leverage the GKE Inference Gateway to intelligently route requests to the model servers, improving latency and throughput. So again, talking about like that parallel call, imagine having all of these agents calling an LLM hosted on GKE, but each agent would know and route through the inference gateway. And then that inference gateway knows which model server hosts the model you need and is able to make sure that you're getting the best latency and the best throughput because it doesn't saturate the GPU or TPU, and it makes routing decisions on which pod or which service has the best utilization, lowest request queue, and also lowest utilization on that GPU cache or the TPU. So being able to kind of tie all these inference tools together, like GKE Inference Gateway, GKE Inference Quick Start, and then our cluster toolkit to be able to build a very performant GKE environment with GPUs and or TPUs, the combination gives you a clear path to not only a very performant production-ready system, but from our agentic architecture to a scalable, high-performance production deployment. Now, what are the benefits to this approach? Agents can reason about failures and find alternative solutions. When you have these traditional microservices built on very complex patterns and kind of restricted workflows, when things happen or failures happen, you then have to build a lot of logic into that to be resilient and also to recover from those failures or potentially offer an alternative solution. Development time increases, and more importantly, the complexity of your application then increases. So we can think about some of these things as resilience and adaptability is a way for us to kind of lower our footprint and allow agents to kind of reason about how to best do that with the tools available to it. Reducing boilerplate, standards like MCP and A2A, they minimize custom integration code. You don't have to worry about kind of building all of these things and then making sure if the API changes on one end, you have to make the proper changes in your code, especially if it's a downstream API or another API that you're not managing, which makes things very complex. With things like MCP and A2A, the agent, as long as the service provides an MCP endpoint, that service will then respond back to what its capabilities are, and then the LLM will just be able to call those tools respectively. So again, being able to reduce that boilerplate code and potentially also any downstream changes that may impact your application because of changes to another API or to another backend system. Of course, the power of generative AI and LLMs really came about because of the natural language interface and being able to just talk the way we normally talk or write and be able to then get things back instead of being guided through very specific UIs. So now the system's controlled and orchestrated through these natural languages. To us, you and I, is a lot easier to deal with and make a more natural interface for users. So this is a great enhancement to this new approach. And then finally, true autonomy. You can develop workflows that run and adapt without constant human intervention. So you don't have to worry about, hey, this workflow failed. I got to set up tracking and monitoring for this workflow. And when it failed, what's our playbook to be able to recover that? Many times the agent, depending upon how you build your agent and how you build the resiliency into that agent and retry patterns, it will automatically continue to retry those or have a failover if necessary. So as an example, in a more complicated method, you could call to an API, but then potentially as a failback, then do direct SQL calls to the backend database to then get information back. So there's different ways to be able to allow that kind of fallback and that true autonomy for your system as each agent is autonomous. It can be built completely autonomous and completely in different frameworks, which A2A allows you to do. So what are the next steps? How do we think about this? One of the things is start small, and this is important. A lot of times we're being asked to kind of take this big bang approach, and hey, we need to be AI ready today. Think about as your services that you have. Think about some of the microservices or modulets that you may have running as containers already that are already exposing APIs. and identify any of these kind of complex workflows in your organization, and then just pick one and see how you can modify that workflow to then kind of drive and build this kind of new agentic pattern into your software development practices. It can start with just one service and one API call, and then build from there, and find, again, the one that has the most value to, as I mentioned before, having all of that resiliency built in, the autonomy built in, and also being able to take advantage of that natural language interface. Build an orchestrator, right? Use the ADK to orchestrate to calls using existing microservices. This is how we go from, existing application sets or existing services that you may have, and begin kind of like almost strangle fig type pattern, where we take one service and we just say, hey, let's build an orchestrator that's going to just call to this existing microservice and see how it does, and then add another microservice in the back end and continue to enhance and drive new application enhancements through this process. But it allows you to then not have to worry about your original code base, leave your your APIs as is, have your teams continue to develop and change or modify code base as necessary, but using ADK, MCP, and A2A to be able to have that autonomy to be able to make these calls separately without having to change your primary code base. Standardize. Wrap your common services with the MCP protocol. This allows it, at least for agent consumption. And you could, using things like function tool or open API tool as a start is a great way, but allows you to at least start consuming your services as MCP agents. And now we have so many ways to consume these MCP agents. Most of your popular IDEs now have an MCP client built into it, or as an MCP host. Gemini CLI, which Google released into the open source, it's a great CLI. Also allows you to connect to MCP servers, both locally running on your machine and remote services. So imagine being able to just have in your CLI this intelligent agent that you can kind of talk to and ask for, and it can continue to ask questions and understand what tools it has available to then be able to then call out to those tools as necessary. So this is a great way to start, at least getting an understanding of how LLMs can leverage the information coming back from your existing APIs and be able to wrap them in your MCP. And that's a very minimal lift, thanks to Anthropic and their standardization for MCP. And tools like frameworks like FastMCP make it really easy to integrate into existing Python code. And there's so many other toolkits out there. Even Golang, one of my favorite languages. There are some third-party, but we are also, I believe there is an early release or an alpha release of an MCP agent, a library for Go. So you'll see that this is going to become very popular, and most frameworks, Python, Java, .NET just released their A2A framework additions, and then Golang as well. So you have all this capability in most of the major frameworks. You have Node.js as well. And then finally, collaborate. Expose your agents via the A2A for discovery and use by other teams, even if it's just internal. A2A is going to provide that framework to give you things like security, being able to identify service discovery, and all of these things that in some cases, really it's about the orchestration and the connection of the agents, not to the APIs on the back end. That's what MCP is for. So I think A2A is how my agents talk to each other and how I can orchestrate the workflow of my agents. And MCP is how my agents then call out to things to get information that they may not have inherently, either locally running on the server as a standard IO tool or remotely through an API call, as an example. And most importantly, the future is not just about services. It's about collaborative intelligence. And this architecture is how we get there. This architecture is what drives that kind of identifying and the new way to modernize your existing application stack and integrate AI into it. So I want to open the floor to questions. There's a lot that I covered. We had a lot of code. I do want to give you some opportunities here. One is we do have some hands-on labs to develop agentic AI workflows, both on GKE, on Cloud Run, and even our Vertex AI. So if you go to gkeailabs.dev, there's a tiny URL and also a QR code to get you to that link here at the bottom, and discuss specific use cases. Schedule, if you have a Google representative, a Google Cloud representative, talk to them and ask for a personal consultation on how we can help you take your existing business applications and potentially leverage generative AI to build out new capabilities and new enhancements, and potentially open up new market areas that you didn't know before by adding this agentic AI workflow into your services, your existing services. And I'm going to ask you to challenge yourself. This year, we celebrate the 10th anniversary of GKE. And with that, we are hosting a GKE Turns 10 hackathon, which the theme of this year is exactly what I just covered, taking a traditional microservice or services, containerized services, and adding agentic AI to your service. There's up to $50,000 in prizes from Google credits and swag, and the winners will be announced at KubeCon 2025 North America in Atlanta, Georgia, and I will be there, so I'll get to celebrate with you if you win. But please, there's a tiny URL there and also a QR code for our hackathon. And I want to, again, thank you for joining. What I'm going to do is I'm going to switch over to some Q&A to find out what kind of, I'll leave these QR codes up as well, but I'm going to switch over to some of our questions to see if we have any questions from the audience that needs to be asked. And please feel free to ask questions. We have some moderators that potentially have some answers for you already, but I'll go through some of these questions here. Question number one, are there going to be patterns such as Envoy that will be created for the intra-agent discovery? That's a great question. We already kind of have that. Actually, there are some patterns about using kind of like MCP as a way to almost be like a registry for your agent card. And there's some patterns and practices running up on there. And also even the GKE product team, we're doing some discovery and some work around how do we make agentic discovery even easier on Kubernetes. And you'll find things like our agent space, which is kind of a part of our Vertex family, to be able to kind of create these agents, place them, and be able to have them kind of discoverable as well. So there are these concepts in different formats and different ways, from designing it yourself all the way through to hosted services. But there's going to be more on the horizon, I guarantee that. Next question. Is the UI connecting to the routing agent a tool offered from Google that looks different from the ADK web UI? Yeah, so that was just a Gradio UI that I was using. It's just open source Gradio, nothing special about it. So what they were asking about specifically was this interface. This is just a Gradio UI that I mocked up to be able to kind of do the queries. But you'll notice I did pull the agent cards as well. So in the Gradio, I have the chat interface, but I also, from each of the agent cards that the host called, it was able to then find each of the agents that were available to it as well. So I kind of added that as a UI kind of interface. But good question. Excuse me. What's the benefit of splitting into 3 agents, router, weather, and Airbnb, rather than having one agent query all the tools? Is there a clear measurable advantage considering with increased token usage and cost? Great question. And this goes back to microservices. Why have microservices and not a module, not a monolith? Because each microservice, depending on the use case, some of these services may scale independently. So, and also in some cases, you might have one agent that is calling a local LLM built into, let's say, Kubernetes engine, another one that's calling out to, let's say, Gemini, or maybe one calling out to our Imagen model or VO3 to make images. So you want to be able to have this kind of leverage to say, let's use the right agent and the back end necessary, and let them scale independently of each other based upon the requests that are happening or the intent. So let's say that, I think it was last year or the year before, there was this, huge event in Austin, Texas, and Toronto, Texas, where there was like within a month or 2 month period, there were two solar eclipses in this one area, and we were just selling out every Airbnb. So at that time, we probably would have had a lot of requests for the weather at Airbnb as an example, but maybe you have other agents that would not have as many calls because, hey, I want to go to Austin and get an Airbnb near the site, and two, I want to make sure the weather is clear before I spend that money so that I actually get to see the solar eclipse, right? So I can independently scale those services and then using things like Inference Gateway and other tools allow you to keep that cost down for those tokens so that you can then take other advantages or other up-level or upstream services to take things like prefix caching and other things of that nature to reduce the amount of calls to potentially an LLM for token. It's a great question. Where do I get access to this code being showed in the demo? The code is all available in the A2A. So this demo example, the Airbnb, is all in the agent to agent repository on GitHub. So if you look up agent to agent, look up samples, the Airbnb one is there, and there's lots of other samples of different types of agents as well, different workflows. So that code that I ran is all available there. I modified a little bit to make it look snazzy, but the gist of it is all there. Can we ask a question? Which connects to both agents? Like what to find accommodation where the weather is windy? Oh, that's a great question. It depends on the LLM and how you were trained and what the instruction set and the prompts were. But in that kind of sense, to say, hey, I just want to go anywhere where it's windy, that's a very long search. So the LLM will probably challenge you and say, well, where in the US? Or, do you want to go in the US or Europe? And it would kind of challenge you back and forth until it started to narrow down enough. But it would potentially continue doing that process to begin narrowing down to where it gets results that it needs based upon the result from the API. So, but absolutely, you could potentially build agents that can be very generic at first and begin reasoning or breaking down the problem. And we use prompts, and then you can have prompts that kind of do like chain of thought thinking and definition, or React agent setup where the prompt kind of tells the LLM how to think and how to break down problems. And then this is a way you can kind of test that and process this. I call this not prompt engineering. When we're working with agents, I call this context engineering, because we're passing context to each of these agents and back. So this is basically how do we engineer to get the best context to make sure that the LLM is fed enough information to make sense of what we want back in a reasonable manner. Is there suitable matching training available for this demo? Great question. Again, the GKEAILabs.dev as well as the A2A GitHub repo has a lot of samples and quick starts. The GKEAILabs.dev has also some full demo walkthroughs as well. Talk to your Google Cloud account representative. Your enterprise may already have credits for some Google Cloud training. So again, reach out and make sure that you have those access. But there's a lot of training out there. And my favorite way of training is just getting down and cracking open some code and trying to break it. Are there any tools for auth or permissions? Doesn't apply for this Airbnb agent, but the company may need to enforce the user has access to one of the agents or specific data in the agent during an API call. Basically, some way for the agents to call APIs as a user and enforce it using some deterministic rules, not what the model thinks. Amazing question, and this is a very hot topic. And I didn't really cover it because it's a whole, that we can spend days just doing that. But yes, you can do things like our Apigee Gateway includes capabilities to do a kind of auth and be able to pass that through. The A2A agent protocol also has ability and it has built-in parts of the framework and libraries for authentication and OAuth and things of that nature to make sure that you can build in security through the end-to-end process. And even MCP now, we're starting to see more libraries add capabilities to add security protocols into your MCP so that the model is not only doing the call, but it's doing the call as you, and that information is passed through. So we're kind of doing pass-through delegation of authority so that hey, this person asked the LLM for this information to this API, and that person has rights, not the LLM. So those are things that are all kind of in process, and a lot of the frameworks and tools out there for that. How would you recommend automated testing? Ben, great question. And this is really because, as I mentioned before, LLM, the reality is this is the return of the result is non-deterministic or stochastic by nature. So we have to kind of build evaluation data sets and then be able to kind of test this process through lots of different evaluation mechanisms. Vertex has an evaluation component, and also there are lots of third-party systems. Weights and biases is an example, great evaluation library and monitoring traffic for these kind of workloads. LangGraph and LangChain have their own kind of evaluation kind of set up a process as well. So it depends on what framework you're building these agents in, and then be able to then kind of give it sample sets. So this goes back to like zero shot or few shot, and give it examples, and then be able to then do evaluations based upon the reply during your testing and automated testing. But it should be part of your CI/CD system, and this is kind of like new way of doing testing in LLMops. But great question. I think this question was kind of similar to the question before, how API calls secured. Can these agents be built in different clouds? Yeah, absolutely. Again, they're just services sitting on the web, so they can have different ports, different URLs. They're following HTTP protocols. So you'll notice that all of my services were being hosted through an HTTP, or it could be HTTPS with all of the security involved. Tie in some OAuth to that as well. When you're running in, let's say, like a Kubernetes environment, you could potentially have a service mesh that's kind of binding and allowing MTLS between all of your services as well, if you need it even a tighter. So again, because these are just traditional containers talking through web services, you're able to leverage all the existing tooling and processes you have for your existing web services today, very similar, and place them in, kind of plug them in directly. Even like Fast MCP, because it's built on Fast API, you can do middlewares, so lots of capabilities there as well. If I've got older services that aren't built for MCP, is there a light touch way to bring them in, or they need a full rebuild? No, they don't need a full rebuild. Actually, you can create a separate kind of like MCP service that just knows to call the underlying API, and then just, basically at that point, you're just telling it how to do curl calls or how to do what endpoints to go to. So you're basically doing like a mapping of the APIs, like go to this path for this, go to this path for that, and how to break it down. So you actually wouldn't have to kind of rebuild the older service as long as it's exposed through some type of API. You potentially could programmatically add an MCP component to it without having to rewire all of your code. If it's not an MCP, if it's not like an API with like a traditional get and post, there is if you can run that service on your server, add an MCP service on top of it, and it calls basically standard IO, and it's basically almost as functioning as if it's calling a command line and running the information from there. So there's lots of different ways and paradigms to do that as well. But that's the beauty of this. It should be pluggable and not a full re-architecture of the application stack. I think I answered this with Ben. What's the recommended approach for automated testing? What's the recommended machine to run this agentic AI microservice? Do we need to use GKE, GPU node pools? So in this example, I'm running on my laptop. So I was just calling an OpenAI endpoint. In this case, I was calling Gemini for the weather, and then for my host agent, I was actually calling a Gemini endpoint that was hosted on one of my GKE clusters. So it could be anything. It doesn't matter. But if I was going to run this completely isolated in-house for my company, let's say, as an example, for an enterprise, and I want to run it on GKE, I would basically run it on GPU node pools or TPU node pools, depending upon the model size and so on and so forth. Look up GKE inference quick start, and you can see that what we actually do is we actually have benchmarked a lot of the most common open source models like Llama 3, Llama 4, DeepSeek, Gemma, and you can then, and Quen, and you can then say, based on my performance, we'll tell you what accelerator runs this the best to reach that performance number that you want to hit, or the throughput, and something we call normalized time per output token. So that's kind of like the end to end from when I first send the response to when the LLM comes back the response. What does that end to end look like? I can target a performance number, and it will tell me my GKE configuration, both my accelerator that I need to use. Is it an A100? Can I run this on an L4? And not only that, but it can also create my GKE or my Kubernetes deployment, including my HPA to automatically scale up my environment, my monitoring for VLLM, and then also all of the configuration for VLLM environment variables that need to configure VLLM to meet that performance metric. So GKE Inference Quick Start, it's a great way to get started and at least set up, start you off with a high performance process and then be able to then fine tune it from there. Good question. When interoperating between multiple agents, you mentioned the state was passed. Is it passed or is it just available via shared memory? That's a great question. It depends. In this case, it is passed. So in this case, I'm using context to pass up some of this information back and forth. But there is different concepts. I'm using built-in ADK agent memory, but you could potentially use things like a Redis cache to be able to, or like our Spanner database, to be able to kind of persist that history and also kind of reference it in a larger way. LangGraph uses graph agents. There's lots of different ways to do that. I was just using this kind of built-in in-memory memory process for this one. Yeah, good question. I think this is how does the state or context keep in sync or replicate between agents? Again, I'm passing it along. In this case, this is not a perfect example, but this is not a production example, but you can see like this is how I did it. Does ADK support authentication on behalf of, and that's, again, some of the things I kind of mentioned earlier. Those are paradigms that are still kind of in flight and are working through, and you'll see there's different ways to do that. But I think security, in the forefront of security, is one of those areas that is changing every day, and you'll see new frameworks and new patterns, and even ADK and A2A are getting updates on a regular basis in terms of how that works. So can you please provide the stack for this development? Yeah, so MCP, LangChain and LangGraph, ADK, and the A2A. So basically that's everything I used. And then I used my Google generative AI framework to call the LLM. But that's all those are the only things I used. And the UI was Gradio, as I mentioned earlier. So that was the stack. Again, if you go to the A2A documentation and you go to the GitHub repository under samples, you'll see all of the kind of requirements and all the different samples there. Is there advantages to running agents in GKE rather than letting Vertex agent engine host it? Sure. It just depends on where you are and what kind of environment you're looking for in terms of tunability, being able to eke out all the performance and drive to your existing platform engineering standards or platform standards for your organization. So if you're just starting out and you want to kind of test this out, hey, Agent Engine is great, and you have a great place to kind of start driving. And with ADK, you can deploy directly to Agent Engine. You can also deploy directly to Cloud Run. And then we're working on also being able to deploy directly to GKE soon as well. Now, what you can do, however, is once you start seeing like, hey, I'm eking out a lot of performance. This is now tightly integrated into my enterprise application stack or my line of business application stack. And my platform team needs to be able to control a lot of the resource management and resource sharing. Usually customers will move into a managed orchestration platform like GKE. And even with GKE Autopilot, which takes away some of that kind of like understanding your node pools and having to worry about all that stuff. You just tell us what kind of compute profile you need, give us the workload and we'll run it for you, but still maintain all of the Kubernetes native tooling and components. That's a great offering for customers as well to be able to handle it. If I were building an orchestrator agent that merges multiple environmental feeds, air, water, weather, what's the best way to handle missing or conflicting data so it'll still give a clean recommendation? That's really all about going back to that context engineering and then building that orchestrator agent that then is able to bring in from either parallel task or the sequential task processing, all of the results from all of the different agents, and then how it should reason about returning back an answer based on the input that it got from all of the agents. So I mentioned, I kind of called out some buzzwords like the React agent pattern or chain of thought. And there's lots of different patterns around prompt engineering. There's a Google kind of published a free ebook, I think, on prompt engineering as well. So do a Google search for that, and you'll see that there's different ways to kind of build out this chain of thought process to then say, hey, when you go out and get this from all these different sensors. When you come back, this is the reasoning process I want you to go through to be able to then reason about a good answer based on the natural request. So. Do we have any multi-tool agent reference code in Java? Actually, yes. If you go to, as I mentioned, if you go to that A2A, there's some examples there for Java. And oops, sorry about that. And there's also some examples as well for other code bases as well. Sorry about that. Let me. I do have some more questions, but I will be able to answer those questions, hopefully offline. We are running out of time. We're at the top of the hour. Lots of great questions. This is an amazing set of questions, very insightful, very topical questions. And I'm hoping that all of you got something out of this, some creative juices flowing to be able to take this to the next level. If you get a chance, do the GKE Turns 10 hackathon, try these AI labs, play around with it, and see how you can bring your applications into the new evolution of microservices with Agentic AI. Thank you very much for attending, and I hope you learned a lot.